Hello viewers, welcome back to the channel. Hope you are doing extremely well. So today we are going to discuss another interesting concept in the geometry. Okay, let's discuss what is it. And before discussing that concept, if you guys are new to our YouTube channel, then don't forget to subscribe it. So let's move on to the editor. Okay, so why today we are going to work on the editor, not on some question is that is because this concept is very useful for the questions that we are going to discuss in future. Okay, so what is that concept? Like till now we have worked on some of the questions, so many questions of the geometry, like finding the size of the geometry, finding maximum element in a geometry, minimum element in a geometry. But till now we have worked on the recursion. But what if I say that we can find all these things in a single recursion or in a single iteration? Like if I tell you, if I give a question in which you need to find all these things, size, maximum, minimum, in one go, then what you will do, you will go and iterate over the provided geometry in different times and then find each value. But we can find all these values in a one go. Okay, this is a concept of traversal and change. Okay, traverse and change. Okay, let's try to understand what we are going to do in this question. Okay, so where is the whiteboard? Yeah, here. So I'm assuming that this is our provided binary tree, and what I'm going to do is that I'm going to iterate over this binary tree and I'm going to find the parameters like size, maximum and minimum of this tree. Okay, in one iteration. How I'm going to do, but the concept I'm going to do is using the concept of stack and the heap. We know that all our variables which we are going to declare outside all of the methods and the classes are going to declare going to get its memory within the heap, and these values which get its memory in the heap are accessible from any part of the program. Okay, and we know that whenever we recursively call over the same function, a recursive stack get constructed out in the memory, and each function get a memory in that recursive stack. And we know that the memory the variables which get its memory into the recursive stack get wiped out during the backtracking. Okay, if you are not getting what I'm explaining right now, I think your recursion concept are not as much clear. Go and watch the recursion video if you have not watched it till now. So let's try to understand uh, how I'm going to do this by writing some code. Just because after writing the code, we'll try to examine that how our requirements get meet with the dry run. Okay, let's directly move on to the editor. So right now we are going to write our code in the editor. As you can see, it is empty, so we need to create our own geometry, and then we need to pass input into it. So I'm not going to write the whole code, I'm just going to copy it from somewhere, and I'm going to copy it from the size function. Okay, even you can do this. Okay, Control A, Control C. Okay, let me make a little changes here. Let me create a method. Okay, at first let me create those variables which I'm going to find out right now. This will be nothing but static int minimum value, static int maximum value, static int size. Okay, size will be the number of fruit, sorry, the number of nodes that the geometry has. Okay, and the static int height, HEI. Okay, let me initialize all these values with some, or all these variables with some value. The min get initialized with the integer dot max value, result dot max value. Okay, similarly max get its initialized with the integer dot min value. We know that why I'm doing all these things, we know all that. Okay, and size get initialized with 0 and height get initialized with 0. Okay, now what I'm going to do, I'm going to create a new function that is a multi-solver, and within that function what I'm going to do, I will do nothing, just iterate over my provided geometry, and during the iteration I will do the incrementation perform some functionality over the all these variables, and at last I will get my desired output. Let's see how we will get it. So what I'm going to do, I'm going to call a multi-solver function and pass this node from here and a variable 0. Let me create this. So public thread public static int. Sorry, this function will be of void type because we don't return any value from this function. Okay, multi-solver node and int tab. Okay, now either we can work on the pre-order part and either we can work on the post-order part. It will not impact our output. Why? Just because right now whatever the work we perform on the variables, these variables already got it memory in the heap, and these variables are accessible in all parts of the stack. So the pre-order and post-order doesn't impact the output. So currently I'm going to work in the pre-order part. So min, what is the min value? Min is nothing but mat.mino node.data and the minimum value. Max is nothing but mat.max of node.data and max value. Similarly, size is nothing but we increment it each time whenever we get any node. Okay, height, we know height is nothing but mat.max of gi height and depth. Okay, depth. Now let me iterate over these by provided binary tree, sorry, generic tree. Okay, so I will iterate over all the children of the generic tree child node.children, and will recursively call the same function multi-solver child and depth plus 1. Okay, so here we are not returning anything like this, and let me print all the data what we have find out right now. Okay, system.out.println. First I'm printing the size plus size. Let me copy it. Okay, system.out.println now max value. Okay, now again system.out.println now the minimum value of the generic tree. Again system.out.println the last thing that is left is height. Height. Okay, so I think our code is ready. Let's try to run it. For the successful running, I need some input, and I'm going to copy my input from the level order line wise generator. Okay, why I'm going to copy my input from it? Just because here I will get a little bit bigger tree. Copy it, and let's try to run here. Before that, let me put my input here, and let's try to run it. So we get a compilation error, missing return statement. Let's see, here we forget to return anything. I think here, yeah, we need to return change its type, return void size. Yeah, it is accepted. Let me copy all this data in my, so size we get here is nothing but 12. Okay, So the size is 12, maximum element is 120, minimum is 10. Okay, maximum element is 120, minimum is 10, and height is 3. And height is 3. Okay, let's try to figure out how all these values get evaluated within a single iteration. Okay, so what we are going to do, we will start our iteration from here. At first, size, max, min, and height, and we have one more variable, that is depth, on which we keep on working throughout the iteration. At first, I initialize my size with 0, max with min value, max with the extreme minimum value, and min with the extreme maximum value, and height with 0. So at first, what happen when we reach here, I will update size, increment it with 1. Okay, now update max with the max of this extreme minimum value and this 10, so it get updated with 10. Minimum, extreme, maximum, minimum value of the extreme maximum, minimum value of the extreme maximum, and this 10, so this get updated. And height, so here my depth value was 0. Okay, just because we passed the 0 at this level, the depth is 0. This level, the depth is 1, so here it will remain 0. Now we do iteration, we reach here, get updated, our size get incremented by 1, it become 2. We compare the max value, and we can see that 10 and 2, within 10 and 20, 20 is bigger value, so it get updated. Minimum value, because the minimum between 10 and 20 is 10, so it remains same. Height, here my depth become 1. Okay, so here I can see my height get updated with 1. Now I move to the next level, here my depth become 2. Earlier it was 0, now it become 1, it become 2. Okay, now I again increment my size with a 1, it become 3. I update my max, check whether what is the maximum value between 20 and 50. It is 50, so I updated with 50. I will compare the minimum value, that is 20 and 50, it will remain 10. Sorry, 10 and 50, it will remain 10. I will update my height, and the maximum value between the height and depth, that is the depth, so I update my height with 2. Okay, now let's move forward. So when we backtrack, this value of depth get wiped out, and we reach to this 20. Okay, now we move to the right hand side. Okay, that is this 60. Here also, here also the value of depth become 2. We get the 2. We compare ourselves, all our parameters, the size get incremented and it become 4. 50 get updated with the 60, and mean will remain same, just because the minimum value till now is the 10 only. Now the height also become 2, and it will remain same, it will not become 2. Okay, no updation will happen here. It will again backtrack. Now this value wiped out, this value wiped out from the stack also. Okay, now the function stack of 20 got deleted, and the 30 iteration of 30 start. So here also the value of depth become 1, and we compare, we increment our size by 1, that it become 5. We check the maximum value, the maximum value is 60 till now, and it is actually the maximum. Okay, so we compare the minimum remains same, and for the height it will remain the same. Okay, we reach to the 70, we increment size with the 6, we increment max with the 7, and we the minimum remains same and the height remains same. Again we reaches to 110. Okay, now here what we are going to do, we will increment the size becomes 7, update the maximum become 110, update the minimum will remain same, and the height, here the value of depth become 3, just because this is level 0, this is level 1, this is level 2, and this is level 3, so here the height become 3. Okay, now the back propagation takes place. This level stack, this stack get wiped out, this stack get wiped out, And now the iteration toward the left hand side start, right hand side start. 30 will call to this 80 and 80 will call to this 120. 7 get updated the 8 for this 80, and for 9 for this 120. 110 get updated with 120 when it reaches to 120 here, and the level minimum and the height will remain same. It will not going to change anymore, just because the maximum height we can see here is 2 only. Okay, so we complete this iteration. And the last thing, because here you can see the size will increment for each node. So here 3 nodes are more, so it get updated with 12 at the last, and we get maximum value 120. Here you can see we get the maximum till now. Minimum is 10, so we get it, and the height is 3. Yeah, just because the 0 1 2 3 it was at level 3, I'm not updated the height. Yeah, okay, you can see that here earlier to find the different values we were performing different iteration, but here you can see just to find multiple values we can find all these values in a single iteration. And this, and we can easily find it just because we know how the stack and heap memory work. Okay, just because these data which were created in this heap memory will easily be accessible from any part of the program, but the data which get its memory in the stack memory which get created during the functional stack creation will get wiped out when the stack when we back propagates in the stack. I hope you get it. Just try to solve it by yourself, because this concept is very useful in the future questions. Okay, so if you like this video, uh, hit the like button. Don't forget to subscribe our YouTube channel. Till then, stay safe, stay healthy.